Right, here's the last three, and this will be a nice segue into the next topics. First, we have A intersect B bar. So the bar means that it's the complement. So we're looking at the A intersection of the A intersect B, which we found before was fairly small. So I'll show it again. The only two things that are in A and in B are 3 and 5. But remember, we still have to take the complement of that. So that means everything that's in U, but not 3 and 5. So 2, 4, 6, 7, 8, and 9. Next is A bar union B bar. Now that means the complement of A union with the complement of B. Anything that is not in A or not in B. Well, start writing that out immediately. We see 1, 2, both of those are not in A. 3 is in both, so we can't keep that, but 4, 6, also not in A. 7, 8 is not in B, so I keep that, and 9. Yep, got exactly the same answer for both of those. And that is always going to be true. The name for this law is one of the two De Morgan's laws. I'll go ahead and write them both. The first one is that, as we just saw in this example, you can take the complement separately and change the union, or change the intersection, sorry, into a union. The second De Morgan's law works the exact same way, but it starts with a complement of a union, and that becomes taking the complement separately and intersection. Those are the two De Morgan's laws. Finally, we have a big problem. A union B complement intersect A, all complemented, and then the entire thing is complemented. So one way to do this, I'll put it down here, let's see, is to work it up piece by piece. So first I'll find B complement intersect A. So let me write the work that's still to be done. B complement intersect A is just the same thing as we saw earlier as A minus B. So looking back at the top, I'll have 3, 5, 8 minus the 3 and the 5. So that will be 8. However, that is complemented. And I'll have to also complement the entire thing. So the complement of 8 is going to be pretty large. Of course, it's everything but 8. So it's 1, 2, 3, 4, 5, 6, 7, and 9. And of course I have to remember to complement the entire thing. When I take that union, it gets even larger. In fact, the only thing that's missing from the big set I have written here was 8, which is in A. So it's everything. With the complement still on there. Now, what's the complement of everything? Everything being the entire set U. I'll write it the fast way. U bar. Yes, it's the empty set, because the complement of the entire universe is nothing. And that opens up the question of being able to do this problem other ways. The problem that we just worked could be done, and this is not a bad way of doing it, but it could also be done using some of the rules that we've seen, some of the properties of the set operations. And that's what we'll do next.